Okay, welcome to video 5.6. We're going to be solving systems of linear inequalities. So there are two additional things to think about when graphing inequalities, and this is a recall. They are line type and shading. So remember that our line types can either be dotted or solid line depending on the inequality. And then we also recall that to determine which side of the line to shade, we use a test point. And then to identify the solution, we always place an S in the area that is double shaded. And then we check our answers if you want to. You can do this by choosing one point that falls within the solution region or solution area, and then you can substitute it back into both of the inequalities to make sure that it's true. So that's an optional if you want to check. So let's look at an example together. Okay, so when we graph inequalities, we're just going to worry about getting them in y equals just like normal. So on this first one, I see x plus y is greater than or equal to 4. Well, I have to get y by itself, so I'm going to subtract x from both sides. So when we do all of that, we wind up with y is greater than or equal to negative x plus 4. And then I can see that my slope here is negative 1 over 1 and my y-intercept is 4, so we can plot those points. So then we plot those points, and then I think it's a good idea to write down that we want to use a solid line here because it is included, because it's equal to. So I'm going to use a solid line, and then we need to worry about shading as well. So I'm going to use a test point, and remember that as long as it's not on the line, the easiest one to use would be 0, 0, and then we can just substitute those in place of x and y. So in the first equation that we're using, the x plus y is greater than or equal to 4, plug in 0, so 0 plus 0 should be greater than or equal to 4, and when we do that, 0 is greater than or equal to 4, and that is not a true statement, so that's false. So I'm going to shade away from that. So now I can go back to my graph. I can go ahead and connect those with a solid line, and I'm sure you can make yours look much better than mine. And then because that test point was false, I'm going to shade on the opposite side, so not towards 0, 0. So I'm going to shade above the line. Okay, so that's it for the first one, and then now we're going to add for the other one, which is already in y equals, which is nice. Now I can just write down what the slope and y-intercept are. So I just wrote y is less than or equal to 2x minus 3, and then my slope is 2. My y-intercept is negative 3, so I can go ahead and plot those points starting at down 3, and then using my slope to plot other points. So then we travel up to right 1 and continue until we can't plot any more points. And then remember, we also need to worry about our line type, and I just changed so that we can kind of keep track of this. I'm going to change it to be in purple color. So I've plotted my points, and I've connected with a solid line, and since my test point 0, 0 was false, 0 is not less than or equal to negative 3, I'm going to shade the opposite side. And then we have a couple of things here that I did not do or did not finish just yet. First, we have to make sure that we put an S in the solution region to show that this is where all the solutions are. And the second thing I didn't do is I don't have any labels on my inequalities, so that would lose me a point right there. So I have to make sure that I label these, and we always label, we go back to the original, in this case, inequality that they gave us. Okay, so now we can see here that I put all my labels on both inequalities. I did all my shading, and I plotted my points and used the right line types and indicated where the solution region is. The last thing that we had written in the notes was that our last step is that we can check to make sure by substituting a solution, a point in the solution region, into both inequalities. And in this case, I think it's a good idea since my two test points were both false, so I had to shade away, which I should have really put a false over here by those. So if I look at my solution region, I think that it looks like I'm going to pick somewhere close to that S. So I'm going to move over 1, 2, 3, 4, 5, 6, up 2. That's definitely in my solution region according to my solution. So 6, 2 is what I'm going to check. So we do this by subbing in 6 in place of x and 2 in place of y in both inequalities. So I'm going to rewrite the first inequality, x plus y is greater than or equal to 4. And then underneath that, I'm going to substitute the numbers in. So when I do that, remember we put parentheses around them to sub in. 6 plus 2, that gives me 8. And I think 8 is greater than or equal to 4, so that is true, which is good because I want it to be true. Then I just did the same thing with my other inequality here by just plugging in both numbers in x and y. And my first one did check this was, or you can write true if you want, this was true. So that checked, and then my second one was true, and that checked. All right, we'll continue this tomorrow. Have a good night.